Hello everyone, this is Jacob Owen, Aruba Systems Engineer. I want to take some time today to go over the Clearpass setup of the dynamic segmentation with downloadable user roles. A couple weeks ago I had put up some other videos regarding the switching side of this and how they interface with a Clearpass appliance that's already been configured. But for this one, I want to do it from the Clearpass side. So as part of this, let's look at the components that are required in order for this to function. So obviously you need a Clearpass appliance, properly licensed and clustered if desired. You have to join the Clearpass servers to the local AD domain if you want to do deep. And then we also need a public sign certificate applied as the HTTPS certificate on Clearpass. This is because the switches actually log into Clearpass to download the user role using HTTPS. So we have to have a trusted certificate in order to do that. So for this demo, the first three have actually already been done. But the next step is we have to create a downloadable user role. So this is actually the username that the switches use to log into Clearpass to download the role. Then we need to enable interim accounting, which has also been already done. This allows the interim accounting packets to be received and processed by Clearpass to keep track of things like total bandwidth used, and provide the ability to do change of authorization, things like that. We then need to add Active Directory as a .1x authentication source. We need to make sure that the NAD devices have been defined with a radius key inside of Clearpass, as well as create the enforcement profiles, the wired role mapping policy, the enforcement policy, and then create the .1x and the MacAuth service. And then we also need switches capable of doing downloadable user roles, 2930s, 3810s, 5400Rs, as well as some of the new Aruba CX switches. But for this demo, it's only going to cover the Aruba OS. And then finally, if we want to do user-based tunneling, we would need an Aruba mobility controller capable of terminating those user-based tunnels and all the configuration. We'll talk about that when we get to that point. So for the first step, we're going to create the downloadable user role, username, and Clearpass. So in order to do that, we go into Administration, Admin Users, and we click one. I always kind of like to use a username that kind of helps me understand what a user ID is for. So in this case, it's an AOSS-DUR. So that's my Aruba OS switching downloadable user role. The password just has to match what I'm putting in my switch configurations. And then the privilege level will be Aruba user role download, and just make sure you check to enable the user. Okay, that's that part. The next step is enable interim accounting. This has already been done, but just to show you where we do that, this is normally a step we always will do when we first come into Clearpass and set it up. We would go in here, we go to service parameters, we go to radius, and then we would set this, which is default false, we'd set it to true, and we'd hit save, and we have to do that for all members of the cluster. The next step is we're going to have to create the Active Directory authentication source. So we would go to Configuration, Authentication Sources, we click Add, and we just create an AD, we call it AD. It's an Active Directory as the type. We'd leave all these settings the same for primary. So here we can either call out a specific domain controller, or if you have multiple domain controllers in your environment, or a customer does, you can actually just use the domain suffix and let DNS do the domain controller lookup for you. That's the more scalable solution. It's recommended for large enterprise and commercial. But for my environment, I've just got a single domain controller. So I'm just going to put this information in here. Connection security. Sometimes it's a little laggy as it's doing the bind lookup, and the freak hangs up a little bit. So once we put in the distinguished name that can do a bind lookup as well as the password for that user, we can do search-based DN, and we can actually now see that we can see the whole Active Directory tree. The recommended base DN is always a level high enough that can see everything that you're going to be calling out. So if you're calling out a user or computers, you have to make sure you're at a level starting above where those users are called out at, or where those devices exist in the Active Directory tree. Okay, so that AD source has been created. So the next step is we have to create the devices in Clearpass. So a lot of times what will happen is people will forget that you actually have to point the switches at Clearpass, but also you have to tell Clearpass to be expecting the devices to come in for authentication. If you don't have that, you'll oftentimes see events in your event viewer that look something like this right here, where it says radius authentication from attempt from an unknown NAD device. So in this case, I had actually forgotten to put in 103010, and it tried to do a radius authentication, and it failed. So where we would go to configure that is we'd go under devices, and we would come in here, and we would put in the name of the device. We'd also put in the IP address, or we can also use a subnet address. So if you have, you know, all the switches in a single building are all going to use the same, you know, /24 switch management subnet, you could actually call that out right here, you know, 10300/24, and just call the name, you know, whatever building switch management. And then we would put in the radius shared secret, and then we verify it. And if you're using TACACS, you would also set that up here as well. These have to match what's on the edge switching, or else there'll be a mismatch. The other important thing to remember is the vendor name here. This is actually very important. A lot of times people think that because we're dealing with Aruba switching, that it's going to be Aruba as the vendor name, but because of the difference in the way the change of authorization works with these devices, we actually have to use Hewlett-Packard Enterprise for Aruba OS switching, but for Aruba CX switching as well as Aruba WLAN, we can use Aruba as the vendor name. If you incorrectly assign these in the device details, some of the COA actions may not work because Clearpass is unable to determine what type of change of authorization it has available for the device it's connecting. And then we just make sure we're doing dynamic authorization, which allows us to do COA, which is a fundamental part of this demo. So we say that, so we're just going to do that for one device. Obviously, we would do that for all the devices. Clearpass also has the ability to scan a network and to pull in all of the discovered devices, switching devices, so that they can automatically be added here so that you don't have to manually configure them. So those have been defined. So now the next step is we actually create our enforcement profile. So this is where we actually are taking action based on the type of device that connects and the method of authentication. So if a printer connects to the network and does a MAC authentication, you know, we're going to return a printer role to the switch. So the way we actually do that is we click Add, and the template is going to be an Aruba downloadable role enforcement. In this case, we're just going to give it a name that makes it easy to understand. And in my case, I'm going to do an IoT device downloadable user role. The role configuration mode is going to be advanced. I like advanced better just because it uses CLI to build the downloadable user role versus kind of what I consider to be kind of an automated process to kind of go through here and use these pull downs. I just like doing it via CLI. So the way we build these roles is actually very easy. First, we identify the type of traffic that we want to match on. So in this case, we're going to do a permit all. So the class is actually called permit all. It's going to match all traffic. And then we're going to do a policy user that's specific to this user called IoT policy. And then we're going to call out the class we just created above. And we're going to tell the user role what action to take on that traffic. In this case, we're going to do an action permit. So we're allowing, this is essentially a permit all on the ACL that's applied to the user role. And then finally, we create the user role itself. I usually like to use a user role name that helps me kind of understand what a device is, so when I connect, it's kind of easy to see, what types of devices are connected based on the roles that are being assigned. The next thing is we're going to reference the policy we just created. And then finally, we have to give it a VLAN ID or a VLAN name. So we prefer to use VLAN names because that allows us to use single policies that map across large amounts of switches that maybe have different VLAN ID numbers assigned, but the same VLAN name. So you may have data or the VLAN name data assigned to VLANs 10, 20, and 30, across 3 different buildings, but I can use a single policy that calls out VLAN name data. And when the local switch receives that radius response or that downloadable user role, it says, oh, I have a data VLAN, and it's VLAN 20, for building 2, or, oh, I'm VLAN 30 because I'm in VLAN 3. So it helps us keep the number of policies down, which can get kind of out of hand if, you have a large amount of differing VLAN names. So in this case, we're going to just use an IoT VLAN. So that has created a downloadable user role for IoT devices. The next one, most of our downloadable user roles kind of look very similar. Especially in demos, it's very easy just to do a permit all and let everything through. But the thing we oftentimes will leverage is the ability to do, per user role access policy. So I can say I'm going to drop IP cameras into the IoT VLAN, but they're going to get a different role than, say, another type of IoT device, because I can do, unique policy assignment even within the VLAN. So it becomes very powerful in terms of how we can micro-segment different types of traffic, whereas before we could just dump them into one VLAN and hope the upstream layer 3 access list would limit things. The other thing that we kind of do is that we can provide a guest captive portal downloadable user role. And the reason I bring this up is because I think this really kind of shows just how granular we can get with different types of traffic within our user role. So what we're going to do here is, so this is a guest user that connects to the wired network and either doesn't have the .1x supplicant running or fails MAC authentication because maybe we have a corporate policy that doesn't allow Windows devices without .1x to connect to our corporate network. So if I had a Windows machine and I plugged into a switch, I want the system to say, hey, I don't recognize this user, they're not running .1x, so give them a guest captive portal role. So the first thing that they would do is they would have to be able to do a DNS lookup. So we're doing an UDP match on port 53 for DNS. Would be the matching of all web traffic. And the reason we do this is because we're going to actually look at this type of traffic whenever we're making policy decisions. It'll make sense whenever a little further along. Equal to port 80, match TCP any to any equal to 4+3. Finally, we're going to do Clearpass web traffic. So what this is actually us matching on any traffic destined for the Clearpass servers on port 40 or 80. It does seem like sometimes this can be a little cumbersome, but you have to remember that I'm building the policy one time, and then that policy then, can flow across, 10 switches, 100 switches, 1,000 switches. So when you think about how much time is invested in making port-based configurations all the time, this doesn't seem to be a lot of work. So it's another thing that IT organizations like about, Clearpass and downloadable user roles. So the next part is we're going to do the policy for this user. So we're going to call it Clearpass redirect. So since we have more than one class, we're going to have to use the sequence numbers. So sequence 10 is going to be class IPv4, DNS action permit, 20 class IPv4 DHCP action permit, 30 class IPv4, Clearpass web action permit, 40 class IPv4 web traffic. Redirect capture portal. So essentially what this policy is saying is if a user gets this user role, they're allowed to do DNS to anywhere, they're allowed to do DHCP to anywhere. They're also allowed to do port 80 and 443, but only to the Clearpass servers because they have to do that for a captive portal, or the captive portal page. And then finally, the last one is the captive portal redirect. So if I try to open a web browser to any other page other than Clearpass, it's going to do a captive portal redirect to whatever has been defined inside of the user role. So what I like to do a lot of times is use the radius VSAs to return the captive portal information versus hard coding it within the switch. And then I just call out where, so this is actually where I can embed the URL itself inside of the user role. Okay, so at this point, this web page would have to be defined on the Clearpass server, but once we get done with this user role, it would be able to do a redirect if an unknown user connected. So the final step is that we do the create the user role. This is going to be a pre-authenticated wired guest. And we're going to call out what the captive portal profile. And we're going to tell it to use the radius VSA, which is referenced above. And we're going to tell it what policy to use, which is the Clearpass redirect policy. And then we're going to do a VLAN name, and we're going to dump them into the guest VLAN. So now in my environment, it didn't matter if I had 100 switches. If an unknown user connected and I had Clearpass set up to do downloadable user roles, they would all be able to, get an IP address from the guest VLAN that's local to that switch, and then they would be able to do a captive portal to, one of the Clearpass servers referenced here, and they would get to those IPs based on the DNS lookup for the URL here in the captive portal profile. So I'm going to save that. Okay, so now the next step is that we're going to create the roles. So don't mistake roles within Clearpass as Aruba user roles, because they're actually completely separate. What roles are inside of Clearpass is think of it as an internal tag that we can use to tag different types of traffic with a tag that we can then use in the enforcement. So we can say, if a device category equals an IP phone, we're going to give it an IP phone role, and then we're going to reference that role in the enforcement policy creation. So the way that looks is I've actually gone in here and I've just created a couple IoT device, IP camera, IP phone. And then I'm going to go in and I'm going to create a role mapping. The thing I like about this is that I can build a single role mapping policy across all of my services. So I'm just going to call it Owen Lab Role Mapping. The default role I'm just going to give as other. And then we're going to start creating some rules. So in this case, I'm going to say if inside the endpoints repository. So if a device is profile and its category equals a void phone, then I'm going to give it an IP phone role mapping. If a category equals IoT, or, and the other nice thing about role mappings is you can do a lot of or statements. So instead of doing, you know, this and this, it can be this, or which makes it a lot easier to take different types of devices and classify them as the same role mapping, and then you can use a single enforcement to match those, you know, 7 different types of devices. So in this case, I'm going to say if inside the endpoints repository, the device name contains CAPE, because I've got a CAPE sensor, I want it to kind of show up as an IoT device, then I'm going to do that. So that means if a device that comes up as IoT or a device that comes into the system with a device name containing CAPE, it's going to be seen as an IoT device. Also, one more we'll do, endpoints repository. If the category equals network camera, I'll call that an IP camera. And then finally, we're going to say if actually, hang on a second. One of the other things I often do is I like to set it up so that if a device comes in that has not been profiled, if it gets authenticated before the profiling has taken place, I'd like to set it up that way so that we can actually tag it and actually do something different with it. And I can talk about that here in a second. Nope, that's online role mapping, mapping rules, add rule. So if the category does not exist, or the category equals unknown, I'm going to give it a profile role. So that means any device that comes through and is authenticated before it has a chance to be profiled, it's going to hit this rule. So by default, what happens then is Clearpass, we can actually write a policy that says, hey, if an unknown device comes in, I want that to be put into a profiler role. So what that means is that Clearpass will actually send a downloadable user role back to the switch that puts the device into a kind of a walled garden that only allows it to do DHCP, which is our primary method of profiling. As soon as that device has been profiled, Clearpass will kick off a change of authorization and force it to re-authenticate now that it has the profiling information. So the way we do that, I always like to do DNS, even though it's not always required. Profile. This works like a standard ACL. There is an implicit deny at the end. So if I haven't called out that type of traffic, it's going to fail. So essentially, I can do DNS, I can do DHCP, but that device can do nothing else until it gets out of this role. usually like, I like to do a re-auth period of every 5 minutes just to make sure these devices are constantly being attempted to re-authenticate. And finally, I usually will put them in, say, the guest VLAN, so they're kind of further cordoned off while we try to determine who they are. Okay. So now we've built the role mappings that map the different types of devices. So, you know, as I said, if a device that comes in and is profiled as a VoIP phone, we're going to map it to a role name of IP phone. If the category is IoT or the device name contains CAPE, it's going to be considered an IoT. Same thing with network camera, mapping to an IP camera, and then if it does not exist at all, we can do a profile. So now, I'll actually go through the process to build out the services. And we're going to do a device MAC authentication. So we're going to call this Aruba Wired. No, we'll call it Aruba Wired Dash. And then that, we can leave this blank if we want it to match all devices. In this case, I'm just going to do it on this one. But right now, I'm just going to accept the defaults add service, but then I'm going to come in here and I'm going to start modifying this service. So the first thing we're going to do is we're going to set up authorization, because since we're going to be looking at the endpoint repository as part of the authentication process, and authorization process, we have to be able to reference that. So we click the authorization here, and then we're going to set up the profiler as well. So for authentication, we're going to use the endpoint repository primarily. And we're going to do an allow all MAC off. A lot of times also, if you want to look at maybe time of day when a device is connecting to determine if it has access, we can call that out as well, but we have to reference the time source as an authorization. So anywhere we're fetching data from, I have to have it listed under the authorization. You know. So roles, here's where we actually are going to reference our role mapping policy we created. And then here's the enforcement. So one of the things that I also like to do, so the profiler tab, this is where it says if any category OS family or the name of the device changes during the profiling process, it kicks off this action. Since we're using Aruba OS switching, we're going to say the radius COA action for this is Aruba OS switching bounce switchboard. So that means if a device comes in, gets put in the profiler role, and then it gets profiled, it's going to see, you know, this classification change and trigger this event, which is the bounce switchboard. Save this. One of the things I also like to do a lot is, as part of the anytime a device connects, I like to have the location of where that device is connecting at, you know, defined so that I can, you know, kind of look at, keep track of where devices are connecting. It's a nice way if somebody says, hey, where's this device? I can actually go in, and since this, anytime a device moves, it's overwritten, the location is overwritten, we can use that. So it's going to be a Clearpass entity update enforcement. We'll say update last known location. It's going to be an endpoint, and we're going to call it last known location. So what we actually do here is we reference the radius attributes that are sent in the request. So we're actually pulling information from the radius request to then apply as an endpoint attribute. So what we're going to do here is we're going to say radius IETF as identifier brackets. Then we're going to do a colon. Okay, so now when we apply this profile to our services or to our enforcement policy, anytime that device connects, it's going to pull the radius NAS identifier and the NAS port out of there and apply it as an endpoint attribute. Come back here, we'll go in here. Okay, we're going to have to add a new enforcement policy. It's going to be called Aruba Wired. Actually, I can just modify the one that was already created. That's probably the easier way. Yeah. So we're going to get rid of this one, which is just a default. And so what we're going to say here is we're going to say tips role. So the tips role is the role mapping that we had set up. So if the tips role equals IoT, we are going to return an IoT downloadable user role. We're also going to update last known location, and we're also going to update the endpoint as known. So inside the endpoint repository, we're going to mark it as a known endpoint at that point. And we just do this for all these devices. Tips role equals IP camera. We're going to have an IP camera there. This is kind of like why I like to name the profile something similar to the role mapping, so it's easy to identify. We're going to update the endpoint as known, and we're going to update the last location. Tips role equals and we're also going to match the profiler, so if a device comes on that has not been seen before, well, we're not going to mark it as known until after it, I don't know, until okay, last known location. And then finally, if the tips role equals other, which means it does not match any of the role mappings, because that's our default policy on our role mapping. Our default role mapping, if it doesn't match, is other. It's going to be, it's going to be a guest captive portal. The only thing to remember here is always set your mapping rules to select all for your role mappings. That way, devices that match different rules will all have the same, they'll all have multiple role mappings connected to them. Otherwise, it'll hit the first one. For your enforcement, you pretty much, it's the first match. Okay, so at this point, pretty much all the Clearpass stuff is set up. So we're essentially returning the downloadable user roles based on the type of device they're connecting. So what I'm going to do here is I'm now going to connect a IP camera to the network. I'll pull up. Up. Like something in my policy. That's the thing I always recommend is okay, so initial roles downloading failed for the role. Just to make sure. It was a certificate issue on the switch. So now you can see that because this device has never been brought online, it's actually being put into the profiler role. And then if you look at this, we're waiting for Clearpass to detect what the device is and do a change of authorization. And as you can see here, it actually now it detects the device as a network camera, access network camera. It issues a COA, which then bounces the switch port. And now you're going to see this device come back online, and it's going to come back online with the correct role, IP camera. And this works for all kinds of devices. I'm going to plug in a lot of different types of devices here. It's going to come online. Okay, so we're seeing another device coming in that's not been seen before. Doing exactly what it's supposed to be doing for the profiler process. Takes a couple seconds. Yep, there's another device. Now, you can now see the COAs doing what it's supposed to be doing. It's kicking the devices offline because now it's detected what they are. So like I said, it puts them in almost like a quarantine role until it determines who they are, and then it says, hey, now you need to go through the re-authentication process. And now this device came online, and it shows up as an IoT device. As is the IP phone, so now we'll check this. Wait for this phone to boot. So I began to notice my IP phone had been profiled correctly, but for some reason it was failing. And I went into the CLI on the switch and did a show logging, and sure enough, you can see here that it's de-authenticating that phone because there's an execution error. So as you can see here, it actually gives you an idea of what the problem is. So it's something to do with the line policy. So let me go in here and look at my IP phone policy. And then, there's the problem. I'm referencing the IoT policy that doesn't exist in this user role. So once you get these pretty much defined, it's very easy then to, find the issue and then fix them, and then it works across the board. So now we'll wait for this guy to come back online. As you can see, I've got the IoT DUI as well as the IP cameras online. right, so now we can see the IP phone has finally come online. So the other thing that we can do is, you know, as we talked about, if you have a Windows device that wants to plug in this case, I've got a Windows 10 device connected. If I plug this in, it does not have .1x enabled. So this would be this like walking up to an open switch port at a customer's network, and I automatically get, you know, a Capture Portal login page. So because the system didn't recognize me, it didn't see me as a phone or a camera or some other type of device that I pre-specified, it just says, oh, I'm going to kick you over to a Capture Portal role. You're going to get a login, and then I'm going to give you limited secure access out of the network. This is really something customers are looking for. The other thing we can do is if we wanted to do user-based tunneling. So let's say we had a corporate policy that said, hey, I don't want to allow you know, IoT devices, you know, access to my network unless they get inspected by a layer 7 firewall. You know, I could actually come in here, I can come down to my my IoT device, and all I would have to do is do a tunneled node server redirect secondary role IoT role. So what this does is this tells the switch to tunnel this traffic to the list of tunneled node servers that have been predefined on the switches. So this could be rolled out, you know, across all your switches via zero-touch provisioning. And then it tells it to redirect it to those controllers, and it says use the secondary role of IoT role. So what this does is instead of being using the user role that's local to the switch, it uses the role that the controller expects, which is IoT role. So in this case, we can save that, and essentially, actually, sorry, there's one more thing we have to do. We have to assign it to a VLAN that is not present on any of the uplinks. And that's just because of the way tunnel node works. So we just, whenever you roll out the tunnel node server configuration, it will actually ask you if you want to set up a reserved VLAN for tunnel node. And in my case, I use 1000. So I will also do the same thing for the IP camera. I forgot to put ID on that other one. Make sure that I put my ID. Yeah, since I'm calling out an ID and not a name, I have to use the word ID or it's going to fail. So now, let me disconnect the devices. And okay, we're waiting for those two devices, then ports 3 and 5 to come online. As you can see, it's now coming up as an IP camera dir VLAN 1000. We do a show tunneled node server users. I can now see that I actually have active up tunnels to the mobility controller, and if you go onto the mobility controller, I can now also see them terminating as wired clients on here. So this is where I can actually apply, you know, deep packet inspection for these devices. They're actually pulling an IP address from the controller. for these two IP ranges. So if I wanted to, I could come in here, you know, and modify the IoT role and, you know, give it, you know, maybe come in and put a you know, policy on there to allow only certain types of traffic, or, you know, to block certain types of traffic, but do it at layer 7, whereas with ACLs, we don't quite have that level of visibility. But this is where, you know, we can really dynamically segment traffic. We can apply, you know, further security policies for certain types of traffic. You know, if I need my guest users to be tunneled back, I can push that out as part of my guest captive portal. You know, instead of them dropping them local, I can just pump them back to the controller and let them take advantage of the captive portal there. If I have devices that have to be on the same layer 2 across a large campus, I can do it with dynamic segmentation. I can create tunnels back to the controller, and now I no longer have to have those massive global campus-wide VLANs, because I just look for the certain type of device, I put it on a tunnel node, and I assign it to a role in the controller that drops it into that VLAN. Well, hopefully today this was beneficial. If you have any questions on how specifically this is set up, you know, please don't hesitate to reach out. Thanks.